The title is Machine Learning Workshop for the Biomedical Image Analysis. So we have a content of presentation includes the introductions, then artificial intelligence, machine learning, deep learning, the biomedical image analysis, which is the purely image analysis part, where I will be demonstrating about you people that how to do the heart disease prediction using CNN-based networks. And then we follow to the conclusion part. So might be some of the participants, some of the professors who are familiar with the machine learning and deep learning, but I will go through with the pace that cover all the starting from basics to the advanced levels of machine learning and deep learning. Then we will shift to the biomedical image analysis. Okay, so as we see over there, that the artificial intelligence from the when I finished my MTech during 2019, so the image processing and the deep learning was doing little bit pace in the India and as well as abroad also. So we have a starting of deep learning over there also. So now this is not a new term. Okay, artificial intelligence. It was an old term which was coined in 1956 by the John McCarthy, and they started their journey that machines can truly think of that particular thing also. And we can see that we can trace the history of artificial intelligence from the World War II also, when when the Germans and they have attacked on that particular Russia and Germans were fighting with each others. So they have developed one machines called Enigma machines, which will decode that particular text message which was sent through the military purposes. So over there, this is a little bit trace route of history through which we have learned the rise of artificial intelligence take place, and as the technology got advanced, we have a new branches and new algorithms will develop. And now on the today's world, it will take a shape of data science and as well as a phase of deep learning. Okay, data science and deep learning. So then Alan Turing wrote his papers about the machines that machines can think of these types of machine can think, so able to do the intelligent things. So this is the little bit of history, and as this image can see that computer science is used in the almost every field. It's like a neuroscience, cognitive science, psychology, mathematics, ranging from engineering also, NLP also. So we can see that the computer algorithms are using in this particular domain. So over here we are tackling that particular biology domain. 1 second, I will be taking that pointer. So machine learning will be using that neuroscience and biology also. So over here we are learning about these things, that how the biomedical image will look like. Then I will take 1 or 2 minutes from this particular slide only. Okay, so everyone is talking about that what is the artificial intelligence, what is the machine learning, what is big data. So how these things are interlinked with one another. So basically we have to just look into that. Artificial intelligence is a huge branch. Okay, so all the things will be covered under the artificial intelligence, which covers about related to the classification algorithms, then regression, then clustering algorithms. So this all comes under the AI and ML. So there is a sub part also, then machine learning also there are CNN, ANN, convolution support vector machines. So SVM and random forest, these comes under the machine learning part. Then we have a regression and classification related problem clustering. So this all comes under AI. Then if we have a data that contains these type of properties, just like as a volume, veracity, velocity, value, and variability, then this comes under the big data also. Okay, and then if we apply some techniques, mathematical techniques, just like as we can apply the mean also, we can apply the standard deviation also, we can apply the other techniques, mathematical techniques through which, so it comes under the statistics and data science part. And then the data visualization and EDA, exploratory data analysis, which also comes under the statistics. Now we are dealing with the computer science, so it all comes under the data science. So these all the things will be interlinked with one another. So we have to classify that all if we know all these things, then we can say that we are comes under the data science field, or we can say that we are a data scientist, or we can say that a machine learning engineer. Then if you talk about deep learning, where everyone is talking about this deep learning. So these are the algorithms, just like a CNN, LSTM, RNN, GAN, and MLP, SOMs, autoencoders. So these all the algorithms and all the technologies comes under this deep learning part. So we have to know these things to if we are expert in the deep learning. So this is a very much the people are getting so much of a confusion that we are doing big data, we are doing data science, and we are doing machine learning, artificial intelligence, deep learning. So we have to stick to the we have some type of idea that this comes under machine learning, this comes under data science, and this comes under the deep learning part. So coming to the machine learning, so I think everyone know that machine learning is a branch of artificial intelligence. We have cleared this note, this definition earlier. So it comprises the theoretical between computer science and real-time data analysis. So we can use this type of analysis with the help of machine learning. Then comes to the real-time environments. So Netflix is using so much of machine learning to give you the that which are the series that are suited for you, for the Indian region, for the American, for the English person, and other things. So it will be using their own algorithms and own type of data to give you the best output. Then we can see Google DeepMind, AlphaGo game, which is using again reinforcement-based learning. So this is AlphaFold. Then comes with the related to the technologies companies which are using that machine learning in real times. Then comes the basic things, supervised and unsupervised learning. So unsupervised learning, we don't know the output of our data. So we are looking for the hidden pattern within our data, just like as a clustering. So we don't know about the clustering. So with the help of, if we have a data which we don't know the output, then we are going to perform the clustering, and we will get the, okay, these are the clusters, 2-3 cluster, and through which we can get the insight about particular data. Suppose that we have a genomics data, we have a population related data, banking related data, and we don't know. So simply thing is just apply clustering and then get our data and get our initial that what are the things we have to proceed, and what are the type of analysis we have to do further. So this is clustering in our data. Then comes supervised learning. Again, we have a data and we know that, okay, this would be the outcome, and we want to perform the supervised based learning. So in this way, we will perform the supervised learning. Over here, two types of problem will come: classification and regression. So classification will classify. So over here in the biomedical image analysis, we are doing the classification problems. Okay, so over here, her disease prediction model will be, we are going to build up a convolutional neural network which will classify the images, whether the person is having a heart disease or not. And then regression, again, with respect to time and other variables, values are getting changed. Suppose that we have to build up a model for the house price prediction, standard classical example. So what would the value of a house after 10 years, after 5 years? So depending on the features and all other data, it will related to this type of problems come under the regression problems. So these definition, we have a discrete value under the classification, and regression, we have a continuous value. So our values are getting increased or decreased depending on our data sets. Then machine learning is a process. So typical examples, those who are familiar with the machine learning. So what we have done, we have defined our objectives, that what we want to do, and then prepare our data accordingly and collect our data, and then we will pre-process our data. So there are some processes which are involved in pre-processing our data. Then we will build up a model, machine learning model based on that, and then we will perform the model evaluations based on metrics which we have supplied, and then we will deploy that particular model in real-time environment through some mobile application, through some web-based interface, through other type of mediums. So we will deploy that particular environment in a real time. So this is a typical environment. So over here we can see that defining objectives. So what does it mean? We have to define the objectives, quantifiable goal, that at what stage what type of problem we are going to face out. So just like as we are going to build up a disease model, then we have to learn about that particular data set. We have to get the data set from the hospitals or from the online repository, Kaggle or UCL. So there are a number of repositories are available through which we can get the data also. Then we will do the data preparation. So these techniques involve the normalization of data. Then we have to transformation of the data. Just like the normalization, we have to use, let's suppose that we have a data of images. I will show you that how I will use this transformation and normalization in our data. So let us suppose we have a data image. So it is composed of pixels. So let us suppose we have an image of 100 cross 100 pixel, and then we have another image of 200 cross 200. Let me take a pen. 1 second. Let us suppose we have an image. Okay, so it is a 100 cross 100, and then we have another image also, which is a 150 cross 150. So we have a different type of images when we click these particular images from that device, just like as a camera or MRI machines. So we have to normalize these images accordingly so that we can get our data in a normalized way. So this could be a normalized data. Okay, so 1 second. Let me take the pointer again. Then we comes to the data preparation. So what we have done over there. So we have a data preparation. We are dealing with the missing outliers values. Suppose that we have some values are outlier, some values are getting missed up. Okay, so we have to supply the there are some methods to reduce the outliers. We can supply the 0, 0, 0, or we can fix the same values. So these are some techniques. Then we will split in the model building. We will split our data regarding to feature engineering. Then we will split our data in training and test set. Then we will perform the estimate performance. We will evaluate our model. Then we will select the best possible model out of it. Okay. Then comes to the model evaluation. So over here we will evaluate the accuracy, and then we will perform the F1 score. We will get the specificity of our model, and then we have to train 2-3 different models, and we have to look into that which one model will perform best on our data sets. So this will come under the model evaluation part. Although this one is the tricky part, we have to look into this. Model building is an easy part, but which one model will work best suited on our data sets, it will depend on your own requirement. So no model is perfect, nothing is so we have to look into the requirement where we are going to use. For take an example, if we build up a model where we have a accuracy of 95% for the related to biomedical engineering, so we can see that it is a good model. But if we have values just like a false positive rate is high and your model is overfitted, then we can't say that 95% accuracy is not good over there. So we have to reduce our accuracy. So we can say that 80% accuracy in a model will be perform much more better than as compared to 90% if we apply that particular model on that biomedical image analysis. Same scenario, if we have a model of 95% accuracy and it will be deployed on banking systems, then over there is no loss of life. Okay, so the money will be spent to if money will taken by someone else, then we can get from other sources also. So but in case of biomedical image analysis, we have to take care of these all type of things also. So 80% accuracy is perform much more better as compared to 95% accuracy, because you don't need to be, your model should be overfitted. So this should be a model deployment, and model evaluation will be a crucial part in the biomedical image analysis. And then we will deploy our model on the real time. So then comes to the problem in the machine learning model. So basically how well our model will perform in the real life. So as we have discussed, I have discussed over there that how our model will be defined, will work, and how our model will work in the real-time environment. That is depend on the two things, basically overfitting and underfitting. First of all, we have calculated the accuracy and prediction of our model, through which we will get that should our model is we have overtrained our model, or should we have to remove the outliers? What are the things should be done so that our model will work perfectly on the given data sets? So we have encountered two problems. One is overfitting and one is underfitting. So overfitting means that your model is doing much more accurate predictions, which we don't need. So, okay, so fault prediction is over there much more. What does it mean? It means that, 1 second. So when our model is performing does not accurate predictions on the testing data. So we have a training data and testing data also. So let's suppose that we have our model. So these are our data points, and this should be a best fit lines. So when we ever give our model, but if we give the so much values, or we will give so much of features in our data set, then our model is getting overfitted. So we do not want this type of model. So in order to reduce, we have to reduce the overfitting in our model. So we will train the unnecessary parameter in our data set. So we have to take care of that particular thing also, that you shouldn't train your model overfitted. Just like as we are seeing that we are getting a 95% of accuracy, 99% of accuracy. So over here in the university, the students are building up their models, and they are showing me that okay, you have, sir, we have built up a model which is showing the 99% accuracy, 95% accuracy. So when we look into that this is our overfitted model. So when I look into their parameters and into data sets, then we will remove the outliers and the accuracy get reduced, and we are getting the best fit lines. So this is a overfitting problems. Then comes to the underfitting. So when it cannot capture the underlying trends of our data. Okay, so this is our best fit model. So when we apply our best fit lines, so if the best fit line will look like this, so that means that which is a underfit model. The models, the machine learning model which we have built, if it cannot identify or cannot capture the patterns in our data, then we can see that our model is a underfitted model. Okay, so this is our best fit line. We have to take care of these things when we are going to build up our machine learning model in the real-time environment, that we have to use neither your model should be overfitted, neither your model should be underfitted. So we have to resolve these queries also. Then it will perform well on the data, but it will perform on the test data. So this will say that when we perform our model on the test data sets, then it will accuracy get decreased. So on the training data, we are getting the 95% of accuracy, 96% of accuracy, but on the models, when we perform on the test data sets, we are getting the 70% of accuracy. That means that our model is underfitted model. So it hampers the accuracy of our models. So this is not a good model. Then we have biases or low variance. So these are all other the techniques through which we can identify that our model is underfitted, and model is too simple. We can learn in the convolutional neural network that if we add so much of layers, suppose we are building up a 2-layer of neural network, then this is simple neural network. So it's a simple one. So it is getting if 100% of accuracy, then it's of no use. So then we comes the deep learning. So this workshop is all about the deep learning algorithms, and I have explained the techniques and the algorithms that are used earlier for the classification of data, the CNN, RNNs. So it's a deep learning algorithms which perform similarly related to human brains. Actually, deep learning is nothing. It's a neural network. Simple if we talk about the CNN architecture, RNN architecture, because all the nodes are connected with the one another nodes. So simple, this is a neural network or a complicated neural network where we have all the layers and all the. So we have the methods, just like as a feature extraction methods, and then we will perform some manual intervention. There is a little bit of manual intervention is required in the deep learning model. So what the basic difference between machine learning and deep learning is that deep learning is automatically reclassifying if there is some type of feature extraction, some type of learning is required, then model will correct itself. So that is the basic funda of a deep learning model. So it's a much more advanced as compared to the machine learnings. So coming to the next. So if we talk about the neural network, so this is a simple neural network. Then comes to a deep learning. So we have inputs values, input parameter over here, then we will assign some weights, and over here there is a functions. Okay, sigmoid function, and there is a function is happening over here. So all the weights will be applied over here, and then we will perform there is some activation function is happening over here, and then we are getting our output. So this is the simplest neural network. If we add one more layer over here, just like as a pen, if I took a pen and we will add one more layer over here, then it's a 2-layer network. If we add one more layer over here, then it's a one more layer network. So in this way, we are going to build up a large convolutional neural network of 120 layers to 256 layers, then 512 layers. So these all the layers will be depend on that particular data. I'm sorry. So this is a simple diagram which shows that how the convolutional neural network will run. So we will getting the insights of this later on as the presentation will go. So we have input data, and then we will do the convolutional neural network. So all the images will be composed of pixels, and then we will perform the pooling operation over here, and then your data will flow from one node to another to another nodes, and then it will get into the end nodes, which is a final fully connected layers, FCC layer. We will call it a fully connected layer, FCC layer, and we are getting the output, whether depending on our input data sample, whether it is a 1, 2, 3, 4, 5, 6. Tomorrow I will show you that a particular things on the MNIST data sets, that how the things will work over here. So this is the simplest example. Then I think few months later, this one things will be happened if if there is someone who has this information that protein structure prediction using deep learning model. So they have built up a deep learning neural network model where the deep learning model will solve the protein structure predictions problems. Basically, what are these? We have a proteins which are solved. They have solved their structure through the deep learning models. So what they have done the multiple sequence alignment, then they have run a deep learning model based on this this architectures, and then they will perform the distance based calculation and some torsion angles related problems, and they will calculate the gradient descent, and through which they will perform the protein structure prediction. So this is the remarkable achievement of deep learning on the in case of biology, or in case of computational biology, in case of drug design. So this is these are the advancements in the case of bioinformatics, or in the case of computational biology, through the use of deep learning algorithms. So this is a little bit of a machine learning part or deep learning part, the basics of machine learning and deep learning, that where we have used this machine learning and deep learning in the real-time environment, and this is the basics of machine learning and the deep learning also. Now comes to my agenda of my talk, that is called as biomedical image analysis. So basically we have a different type of images, so ranging from X-ray image, then we have a ultrasound image, then we have a MRI image also, then we have a PET scanning also. So basically we have images of different types which are used in the radiology department to analyze the internal structure of our body, and based on this, doctor will take your medication and gives you the proper medication, that what are the problems are available in our, or the person, or the uh, uh, person is infected with the disease. So based on this scenario, they will do the analysis. So how we can apply that biomedical image, deep learning and convolutional network on the biomedical image analysis, we are going to learn in this particular image. So basically, if you talk about different modalities means that what are the things that are available in the form of images in case of biomedical imaging. So we have X-ray images, okay, computed tomography, which is X-ray. Then we have a magnetic resonance images, MRI images. Then we have a single photon emission computed tomography, SPECT. Then we have a positron emission tomography, which is a PET imaging. Then we have ultrasound imaging. So these images are used for the different purposes. Basically, these are X-ray, then this is the MRI, this is the MRI, this is a PET scan, then this is a CT scans. So when we visit in the hospitals, so sometime doctor will recommend that, okay, we have to perform the X-ray, we have to perform the MRI, we have to perform the CT scans also. So what are these? So let's look into this. So we have a X-ray. Okay, so X-ray where we have you using, although it's a cheaper one, okay, and developed earlier. First time the X-rays will developed. So this is the mammograph image. Okay, particular this is used to detect the breast cancer in our body. So X-ray is used where we have to identify the body is infected with calculus. Okay, calcified. What does it mean? That where we have a presence of calcium is there. So for the identification of breakage of bones, for the identification of where the presence of calcium is more, we are going to use MRI. Suppose that we have to identify the skull, breakage of skull, bone in our skull, then we will perform the X-ray. And if we have to perform then the question arises that why the X-ray is used for the breast cancer predictions. Actually, the mammography, it's composed of tissues, okay, and tissues are composed of calcium. So when we have a more concentration of calcium in our body, where the calcium concentration is more, we can use the X-ray, although it's a cheaper one. So this is the X-ray images. So over here it is used that it identify the calcified tissues. So over here, that as we know that if we have a little bit of science experience, that our body is 70%. Our body, if you talk about little bit of cells, then the 70%, 7 to 80% cell is empty. There is one hypothesis that if we remove all the empty space from the inverse, then all the particles in all the atoms will becomes under a sugar cube. So what does it mean? That air is surrounding us, if we talk about in the molecular levels. So that means that air, if the dark regions that are presented over here, the air will be there. Okay, although it's a form of blood, but if we took into the atomic levels, then we will see that atom, electrons and protons. So we have an empty space, lot of empty space. So X-rays will detect those empty spaces over there, and then calcified spaces where the calculus body is available over here. In case of bones, then we will use that particular X-ray. Then comes to the CT scan. Okay, X-ray CT scan. So similar case for there also. So it is used. X-ray CT scan is used over where we have a soft tissues. What does it mean? That for the identification of soft tissues, we will use CT scan, X-ray CT. Okay, so over here for the brain, as we know that we have a brain is composed of tissues, small cells, and then we will be using that particular CT scan for that purpose. Okay, then comes to there is a new type of technology which comes to the X-ray CT. CT scan, which is a 3D scans. Okay, so for that we are going to get a 3D image of our particular object. So the technology get advanced, so it will show you the all the shaded region in our body, just like as all the grayscale, which where the density of mass will be available over here. Let's suppose that there is an infection in our lungs, and there is a tumor in our lungs, or some type of abnormality in our body. Then it will, there is an enhanced shadow is visible over there, so it will be available over the uh, grayscale sides. So that will show the different organs of our body. So to check that particular things, we will perform the X-ray and a 3D scan of our body. We can take it in such a way that for the stomach, the shadow will be different. Okay, for the lungs, the shadow will be different, and for the heart, the shadow will be different. Okay, so over here we can see that this is the different shadow. If we took the X-ray CT of our stomach or our liver, then we are getting a different shadow. So for that purpose, we are going to use X-ray CT. Then comes to the PET scan, okay, which is the positron emission tomography. So when we visit in the hospital, so someone is saying that doctor is said to you that you don't have to eat anything till for 5-6 hours, and you are sitting idle over there, and then they will perform that PET scan. So what they have done over there, they will give some type of we can say that some type of chemical or medicine, which is comes under, I think, bromine. I'm forgetting the name, but they are giving you some medicines. What is happening over there? This is circulating in our body, and the things which are we have to cut, that the chemical will be available over there and particular point, and then we are capturing that particular image, and we are getting the different spectra. Okay, we are getting the different range for that particular chemicals, and this comes under the PET scanning. Okay, so for the brain we have a different areas. For the hearts, for the lungs, we have a different area. So this is giving you a different perspective and much more information as compared to the previous ones. So although it is much more costlier as compared to the previous methods, so it will depend on the ranging that where you are performing these type of X-ray or PET scans or imaging. So it is a much more costlier. We can say that in the simple word for the India. Then comes to the MRI. So again, it's used for the magnetic resonance. So over here, this is used basically for only for the soft tissues only. Okay, so to check the shadows areas for the soft tissues, which are composed just like as for in case of neurons, we are going to use particularly MRI. So MRI is the best suited thing to check that whether the person has a tumor or not, whether the person is infected with any type of disease, whether if person is suffering from the accident, then the doctor will perform that MRI. So we have to perform the MRI. So basically it is used for the soft tissues only. Although we can perform the MRI of different body parts also, but for the brain related, typically MRI is used in everywhere. So this is the basic of CT scan and MRI imaging. Then comes to okay, so brain imaging, X-ray, CT, MRI, and PET scan and MRI. So these are some basic terminologies. Then we comes to the 1 second. There are 4 persons. Okay. So medical image research application. So where the medical imaging research application will be takes place. So where are the current understanding of this physiology department? Then what are the basic fundamental of imaging which is used? Then we have applications of imaging, and what are the things and what are the challenges that are associated with that image processing, and then instrumentation of image acquisitions. So this is the fundamental question, that how we are going to capture that particular biomedical image analysis. So for that we have instruments which are much more costlier. So this domains is not an uh, we have to take care of a lot of things, and there is a lot of research is involved, and the instrument cost is very much high. So in order to reduce the cost into instrumentation, so we have worked on that particular thing also. Then application and intervention, so we have to develop the computer image processing algorithm which will process our data much more faster as compared to the previous ones. So over there is a mix of computer science domain as well as biomedical as well as biology also. So over here interdisciplinary research is going on to develop a new type of algorithms, comes under the biomedical image processing. So as we see that where the work is going on, although in the Google or although in the research applications, there is a work done in the collaborations. So hospital is available over here, and then there is a research center is available over here, and they are getting the data of patients, and based on this they are developing a new algorithms and providing a new solutions to the community, research community, and to the audience also, to the peoples, to the doctors, to the all the practitioners. So we have to work closely with the with the with the computer processing and analysis and modeling also. So then these are the modalities of biomedical imaging. One second, there people are joining, so I think I have admitted it. Okay, then these are the modality of medical images. Medical imaging modality, that we have to take care of the energies, then we have to take the anatomical values, then psychological values, and functional values. One second, just give me then functional, then external and internal combinations also. So we have to take care of all these things. Okay, in the case of to perform the biomedical image analysis. So particularly if we talk about the biomedical image analysis, so this is a electromagnetic spectrums. So all the images comes under this. Radio waves is coming over here, 10 raised to power 3. Then we have a TV waves, radar wave, microwave, infrared wave. I think everyone is familiar with this with this electromagnetic spectrum also. So we have ultraviolet rays, visible lights also. Then we have gamma rays, cosmic rays also. So this is the electromagnetic spectrum, and we are X-rays are lies over here, 10 raised to power minus 10. So this is the wavelength in meters. Hertz frequency is in 10 raised to power 18, then 10 raised to power 3. So this all comes under this electromagnetic spectrums. Then if we talk about clearly, we can say that these are the frequencies of PET imaging. So PET imaging comes under gamma rays, which has a 10 raised to power minus 11. Then we have a UV rays, which are used in 10 raised to power minus 5, which are used to cure the X-rays also. We are used to cure the cancer related patients. Then we have MRI images also, comes under the radio wave, which is the electromagnetic spectrum of 10 raised to power 1 to 10 raised to power 3. So it's a wavelength. So the person who is working in this domain have some type of knowledge about that the electromagnetic spectrum, that how the ultrasound and how the microwaves will look like. And this is the 10 raised to power 15 is our visible lights, which is used in the pathology to identification of these bacteria and viruses through this and through these microscopes. So visible light is also important. Then X-rays for the bones and soft tissues. If this is the 10 raised to power minus 19, 10 raised to power minus 17. So it's showing off wavelength of different biomedical images, that on that particular what type of wavelength is required to perform the biomedical image analysis. Then comes to the again some parts that where we are going to use the medical image modalities. So these are the areas, some of the areas. We have external sources also, then we have internal sources also, then we have a combination of external as well internal sources also. So for that external sources, we have X-ray radiograph, then we have X-ray mammography also, then we have a X-ray computed tomography also, then we have ultrasound images, then we have optical transmission and trans illumination images. So these are the new type of technologies where the illumination will takes place, and we are getting the images with the much more and enhanced format. Then we have a SPT. So this is single photon emission tomography. Then we have a nuclear medicine also, positron emission tomography. So this is the PET scanning. Then then we have a SPECT. Okay. Then we have a combination of external and internal sources also. So over here, what are these? MRI, PMRI, fMRI. So we have a different type of difference between these MRI, PMRI, fMRI. So we don't have to go into that. That is not an agenda of our talk today. But yes, there is some type of little bit difference through which we can identify that this is fMRI. So it's a part of a radiologist or a researcher or a doctor who is working on this type of domain, that how this what are the difference between these. Then we have optical fluorescence images. So there is some type of optical phenomena or fluorescent which we medicines which we take inhale, and then we were getting the rays over there, and then it will glow up. So it will give us a fluorescence that okay, if we have to identify the missing that tissues or a tumor or a infected area within our body, human body, the optical fluorescence imaging technique will be used. Then we have a electrical impedance imaging. So through some electrical signals, we are getting some type of images, and then we are going to do the perform analysis. So these are some advanced topics. Someone can do the research on these topics, then publish the papers and work on that research communities. So then again, medical modalities. So for the radiology departments, these are the things which comes under the radiology. Then under the visible light imaging, where we are going to use that visible light imaging. So this is the dermatology related to skins, then endoscopy, then other organs. So we have to identify that visible organs that are present in our body. Then we are going to use that medical. Then we have a microscopy imaging, light microscopy, electron microscopy, transmission microscopy, then fluorescence microscopy. So these are the techniques related to microscopy that are used to identify the tiny particles, just like the bacteria and viruses presence of these type of things in our body. So if we have to identify this, then we have to use these techniques, microscopy. So in the pathology department, they will take your samples, and then they will analyze through the microscope. So they will use these type of technologies to identify your that person is infected with that disease or not. So they will identify this. Then we have a multimodal imaging. This like a CT, MRI, PET scanning, MRI SPECT, and X-ray, then other modalities. So these are the techniques. These are the modalities which are used in the case of a biomedical image analysis. And a person is, if we are working with closely with the hospitals, then we have to take care of, and we should know these type of things, that okay, so this one is this, we are getting image from that particular hospital, from the department, then this comes under these categories. So this is the basics. Then comes to the physiology to information processing. So what is happening over here? Physiology means that physical structure, appearance of our body. So understand the image medium. Okay. So what does it mean? That if we are getting the tissue density, that what these are the features: blood flow, perfusion, cardiac motions, then physics of imaging. So transmission of X-ray, emission of gamma rays, then MR imaging, and imaging instrumentation. That means that which type of instrumentation and where we are getting our data. So we have to collecting our data, then signal to noise ratio. So that which means that if our instrument has some type of error in our data, in that particular instrument, then it is not able to perform the good capture of that particular image. Then we have to look care of the resolution also, that what is the clarity of our image. I will show you that some of the images later on that which are not captured accurately by that particular MRI machine. So the noise is available over there, and that are not used for the our research purpose. So these are the things that we have to take care of when we are going to design our machine learning models. So we should know these basics, that when a person is working in these domains. Then comes to the data acquisition methods. So this is a continuous of this information processing. If we have to work, then comes to data acquisition methods. So image formation, then we have a filtering methods, post processing methods. So then we have a back projection method, and iterative and Fourier transformations methods. So these are the some of the methods. There is a filtering methods. Okay, so everyone is aware about these filtering methods. When there is a uh, uh, there is a flow of social media, just like as Instagrams and all other social media apps, then everyone is know about these filters. I think definition is know the filter. So we have some type of filters through which the information is processed, and what they have done, they are changing the pixel intensity of that particular image. So your image get changed. Okay, suppose that we are applying a filter which will reduce the value of image up to 128, from 256 to 128. So our image get converted into white. So these are some type of filters that are used for the image formations. So then image processing analysis, we are using the image enhancement techniques. We are going to use transformation also. So image enhancement is basically used to enhance the image quality. Okay, so now how the deep learning will be used? Let's suppose these are the pixels. So let's suppose these are the pixel values, 80. So then 10, 15. So what they are doing, if we enhance the image quality of that particular pixel, they are going to change it 15. They are going to change it 50. So it will again depend on the color to aspect ratio, that how we are going to build up. You can see that there are some websites which are performing this type of image enhancement. And I think I can remember that I think 5 to 6 months earlier, the Google has done some type of things similarly. So what they have done, they have performed this image enhancement, and through which, if we supply a black and white image to that particular machine learning model, they will change it to the color domains. So in this way, they are changing that particular, doing the image enhancement also. Excuse me, someone will tell me that I am audible or not, because there is some type of error will shown on my screen that so I'm audible.
Yes, sir.
Okay. Thank you. Actually, there is some pop-up messages comes on my screen, so that's why I'm asking. So if you talk about the image enhancement, so in this way, the Google has done some work, and then through which we are converting that image enhancement techniques. And then there is a one techniques through which what they have done, they have changed the values of black and white to color images. So they are generating the black and white images to color images. So they are using the same techniques, transformation and then enhancement techniques. Then comes to the performance. So what are the negative performance, general performance or measures which we will took to perform the analysis of our images? So everyone is aware about these confusion matrices. This is a confusion matrices, we will call it. So we are going to use the positive and negative. Okay, so positive object was observed and negative means object was not observed. Then we classify these things into four parameters: true, positive, false, negative, true, negative, false, and positives. So based on this, true, positive, false, negative, false, positive, true, positive, I think most of the person will confused in this, that what are these thing. Then let me clarify this thing for the uh, 1 second. Someone has raised the hand. ask her to unmute. Okay, so we will take the doubts in the end. So let me okay, so this is confusion matrices. So over there we have predicted classes and then we have actual classes. So positive is true positive and false negative. Then with false positive, and these are negative domains and these are the positive domains. Okay, so what is the sensitivity through which we are going to specify the sensitivity? So sensitivity is telling us the true positive rate, and then specificity is telling us the false positive rate. So in this way, we are going to check it out, that sensitivity and specificity of our machine learning model. Then we have a precision values also. Okay, so this is telling us the true positive and false positive rate. Okay, then we have a negative predicted values. So this is telling us the true negative values and then false negative values. So in this way, we are getting our confusion matrices, and these are the formulas through which we are getting the accuracy, sensitivity, and specificity of our machine learning model. Coming to the next, then we will draw the ROC values, which will predict us that how our machine learning model will behave in the at the time of training and at the time of. So ROC will predict to that we are training our machine learning model, and at a particular time it gets stopped. So what does it mean that when your model is getting trained, so how much we are getting the values, our model will remain fixed. Okay, so we are not getting the much more values. So under that particular ROC values, this comes under the area AUC, area under curve also. So much more the area under this part, our best the model will be. So ROC will tell us it will perform the better overall classification ability of our model based on some values. And then this is the random probability. It will show us the machine learning, how our machine learning model will work, and whether we have done train our model very well or not. So by checking the ROC value, if we look into the research articles, one second, let me take an eraser also. So by doing the checking the ROC values, we can once again, by checking the ROC values of a particular machine learning model, you can predict that this model is a good or not. So let us suppose that your model is touching that 0 to 1. So yes, this value is ranging from 0 to minus 0.9. Okay, so if your model is running this is the model, then you can say that this is a good model. By checking this ROC curve only, you can get that we have done a good model or not. Then this is a much more enhanced way through which we are getting. So this is the AUC. So if your model is doing like this, then this is a good classification. And if your learning rate is like this, true positive rate is look like this, then it is a better, and it's a rejected one. Okay, and this is a good line. If your model will look like this, then we have negative values. So this is a worse effect. So it will tell us all the value predicted classified values and true positive rate. So it will depend on the true positive rate, that how that, and then it will tell us the false positive rate also. So by just checking the ROC values in our machine learning model, we can check that okay, they have done a good work or not good work. So this is the ROC, about the ROC values. So similar thing, specificity, sensitivity, and accuracy, we are going to check these parameters when we build up our machine learning model. And then we can do the histogram equalization also. So this is the machine learning techniques. So where we are going to use this? So we are going to use this in the mammography. Okay, so over here we have a different image. Okay, and over there we have a less information is available over here. Okay, so let's suppose that that lady is suffering from that breast cancers, and how we are going to predict that? So through image enhancement techniques we can get. Okay, so these are the areas where the affected areas are happening. So these are the areas where there might be a case of cancers. So in this way, the image enhancement technique is through histogram equalization method, we can detect or we can identify the different different um, uh, different images, and we can get the different angles of that particular same set of images. So when we see a MRI, you will see that that doctor has a certain number of small snapshot sort of a particular image is available over here. So what they have a different section of that particular image, and based on this image enhancement techniques, there is a different section of that particular image also. One is darker, one is lighter, one is different aspects. So based on this scenario, they are just checking. So this is a simple technique, image enhancement, but the uh, the results are much more advanced as compared to the traditional techniques. So by just doing the simple image enhancement, we can detect that whether a person has having a particular disease or not, because we are getting so much of informations. Okay. Hello, I'm audible. I think my screen has stuck. Okay. Actually, my screen is stuck over here, so that's why I'm audible. Fine. So, so in this way, we are getting much more information, enhanced information through the image histogram image equalization methods also. Then comes to the my actual topic. So in the early, I have told you that this would be a roller coaster ride. So we have done the basics of machine learning. Then we have jumped to the biomedical image, some type of aspects of radiology. Then now comes to the pure computer science related part, that how the biomedical image analysis will be takes place. So over here, I'm going to give the brief demonstration about that how the biomedical image analysis will takes place. So basically, I've shown this diagram earlier also. So we are talking about this neuroscience and biological domain also. So basically, over here, I'm working with the heart diseases. So this is a disease called as hyperkinesia, where we have a muscular activity, okay, increased muscular activity of the heart images, hearts. So we have a excessive and normal movement of, and it could be a combination of both. So this is a disease called as hyperkinesia, where we have a muscular activity where we have a much more or muscular activity. Our heart is pumping much more blood or much low blood. So this disease we have data sets. Then hyperkinesia is also defined as it's a childhood movement disorder also. So what does it mean? That it from the person who has or a child who has an age of 6 years, 8 years, 10 years. So he's also suffering from that particular disease also. So there is another disease called as hypotonia. So if the person shows a negative sign, then it comes under the hypertonia. So these are the medical terminologies. So if a person is working on these domains, then you should know this, because if you will build up a machine learning model and it will work, uh, and you don't know how the actual biology or how the science behind that particular disease, then it would do a blunder for us. It would be a great disaster. So that's why if we are working in the biomedical domain, then we have a precise and accurate knowledge about that particular disease. We have a data set working on this domain. So these are some symptoms. Overloading of cardiac schemes means that heart attack. Then we have coronary artery disease, then cardiomyopathy, then head turning into left eye shift. So this is a disease. Okay, so someone is looking into this, then person is looking into that particular direction. So this is a shift eye position. Then facial movements, someone is showing the I'm sorry, some abnormal facial movements, then slow and uncontrolled movement also, then abnormal movement of muscle, abnormal reflexes, and heart attack also. So these are some of the symptoms. related to the that particular heart disease. If a person is suffering from this disease, then we have like that heart disease also. Then we have a diabetes, overweight, obesity, also poor diet, then physical inactivity, excessive consumption of alcohol. So these are some basic symptoms which are responsible for that particular disease. If we talk about this statistics, then uh, then we have data of United States. So approximately 6 million people will die of this heart disease every year in the United States, and everyone is for death. One is responsible with that heart disease related to heart attack also. So this is a much more severe disease. If we talk about this disease, then this is the leading cause of both men and women, and uh, half of the death is due to reported this disease were related to the men related to the disease also. This coronary heart disease, okay, CSD. So it is kill over CSD is also kill approximately 3,70,000 people in the United States. So every year, a lot of person will be suffering from this disease, which shows that how much important this to identify and to work on this particular domain is. If we talk about in terms of money, then we have a lot of money involved in this domain. So so just like the healthcare companies are working in these domains, so there is a huge cost is involved to develop a machine learning model and to develop machines which will identify that particular disease more accurately, and to develop algorithms and to make a new algorithms. So lots of money is involved in this domain. So if someone is working on that particular thing, then the more statistics. Okay, so if we talk about this MRI images and about the heart, so this is the in the I think in the classes, school classes, we have learned about this aorta. Okay, largest artery in our body. Then we have a myocardium. Then we have a left ventricle. Then we have a interventricular septum. Then we have a right ventricle. Then try. Then we have a uh, then we have valve also. Then we have a right atrium also. So this is the basics of this heart which we have learned during our school times. Then this is a typical MRI image. Okay, so this is the one cross sections which I have put it over here. So when uh, so this is a one image. So when the MRI machine, so person is lying over there and particular bed, and this is happening over that MRI is taking place on that particular machines, magnetic resonance reference image is taking place. So this is a one cross section. So when we combined these cross sections one by one by one, so we are getting lots of images. Okay, lots of images on our data sets, and through which we are getting a different section. So this is a one particular image of that particular disease related to the heart. So if we combine these all images, then in this way our heart will look like. Okay, so over here we can see that okay, so over here we have a person is suffering from that particular disease, and there is a less flow of blood. Okay, so it is not working. So these are the different areas through which we can identify that okay, so these are the areas where there is a less flow of blood. If this person is uh, working, if the person is affected with this type of disease. So over here we have a excessive flow of blood also. Then we have a normal flow of blood also, low flow of blood also. So we have to identify this with the help of a heart disease, which is a convolutional neural network. So these are the review literatures. I have added some of the papers. If someone wants to work on this domain, then he can get some ideas from these papers that they have worked in this domain, and they have make their machine learning model, and they have get the accuracy of this much of accuracy. They have get 96% of accuracy, and then we have get of uh, uh, results. So these are the some review of literatures So they have done during 2017, 2018. So this is much more review of literatures. So objective of our workshop is to get the data for the convolutional neural network, and we can perform the pre-processing on that particular data set, which include the removal of outliers, removal of noises also. Then we can use the CNN based computable format. Then we can use the herd disease classification methods, and we can build up a convolutional neural network based on this uh, uh, based on this heart disease. Okay, so research methodology, a typical to this research would be that first of all we will collect our data from different sources, and then what we have to do, we have to pre-process our data. Okay, so what does it mean? That where we are going to remove the outliers, that we have to remove the noises also, and then we have to do the certain pre-processing techniques. Then we have to use the data fusion techniques once. Then we have to use the data fusion techniques. So in the data fusion, we will data fusion. What we have done is, let's suppose we are working with different hospitals A, B, and C, or different departments. Then we are going to combine this data, okay, to build up our machine learning model. So these are the techniques. Or suppose that we are getting the different patients' data, okay, from the different areas. Then we will do the data fusion techniques. Then we are going to do the normalization techniques. So again, in the normalization, I have in the starting, I have told that image is composed of pixels. So we have a different size of pixels. Okay, 150 by 150, 100 cross 100, might be some image of 50 cross 50, or some image cross of 250 cross 250. So there might be a possibility that we have to normalize our data so that our data would be in a proper way. We are going to use the add some values also. If there is some missing values, then we are going to add over here. Then we will run that CNN model, and then we will do that model generation and training, and then we will perform the model validation and testing on that predicted dataset model. Okay, 1 second, let me. So we are going to perform that model prediction on that particular data sets. So in this way, this is a typical pipeline which will be used in, I think, in almost every researcher, every doctor, or every practitioner who is working in this domain, biomedical image processing, will work on this, will follow this type of methodologies. So system requirements. So what these are the system requirements that, okay, so we should have a Windows or Linux based distribution also. Then there is software called micro dicom viewers. Okay, so for this workshop we don't need this software. Okay, actually I have converted these images and given you a small data set so that you can work on this directly. So I have converted all the images for you people. So we have Anaconda. So I think everyone is familiar with this Anaconda. Then we have you can use to develop a front end based. We can use that mobile application, or we are going to build up a website. I think tomorrow Aman sir will be going to demonstrate to you people that how this thing will work, connect with the front end. So in the today's lecture, we are going to learn about this basic about that HTML and CSS and JavaScript. So then we need the Python also. So we can work on the Python 3.6 later on version. Then we can use the later on upcoming version also. Then some of the libraries we have to use NumPy also. We have to use TensorFlow. Then we will use OS also. Then we are use CV2 also. So these are the libraries that must be installed on your devices when tomorrow we will we will perform some live demonstration on that particular PC. I will perform on my laptop. So these are the libraries, and these are the software that needs to be installed uh, on your systems. Then comes to the data collection and pre-processing part. So if someone is doing his or her research in biomedical domain, then this is a very crucial part. Okay. So when I was doing my research during my masters, so we have a data, although we have in-house data is available over here, but the data is we have got from the IGMC Shimla radiology department. So over there, from there we will get our data, and for that we have to sign some ethical concerns, also uh, some uh, some ethical concerns related to the data. So we are not going to share the personal information and other things. So these are the things we need to take care of this while we design or when we work on this biomedical image domains. The ethical concerns are much more important related to the data privacy also. So we have to take care of that thing also. Then the data which we got initially was in the random format. Okay, 1 second. So our data would be in the random format. What does it mean? That when we got our data, it's unlabeled data. We don't know the patient name, we don't know the history of the patient, whether where it's coming from, because on the MRI it is written is available over there also. Okay, so what we have to do, we have to slice these data, and then we will get, when we get our data in the final form, then we don't know. Okay, so over here we have to, when we got our data, then we will label it our data. Okay, so these are data is available in different formats. Then I have labeled it in the form of normal images. Then the person who is suffering from this hyperkinesis disease, then we have labeled the data. Okay, these are the person related to normal disease, and this is the person that are related with the hyperkinesis disease. And then we have a normal image. So data set would be that I have right now is 13,000, approximately the 13,000 images which we have is normal images. Then 22,000 images approximately which we have got at initial moment. So 22,000 images is for the persons who are suffering from this disease, and the person who is not suffering from this disease. So we have a 13,000 images approximately. So we can see that total data set would be approximately 36,000 images. Then we will perform our step number 2, which is this pre-processing data. So after pre-processing our data, what does it mean? So I have told in the initial that when we are discussing about this radiology, that biomedical part, that we have a noisy data also. We have a incomplete images. So when the MRI will be taking place on that human body, some of the images which are incomplete, some of the images which contain noises, some of the images which are blurred images, some of the images which are distorted images, then we have a corrupted images. Then there might be a possibility that that there is some type of error in our instrument also. Then there might be a possibility that the person is doing some type of movement. I just remember that when my grandmother is visiting the doing that particular thing, so he is doing for the MRI, so he is just doing little bit shaking because she is too much old. So we have to hold her tightly so that the X-ray image will get, MRI image will get much more in this way. So we can relate this thing. So MRI images will be happening over there. So noisy images will be generated at that particular moment, then blurred images will be generated, and distorted and corrupted images will be generated. So what we have to do, we have to pre-process our data. So when we do the pre-processing of our data, then we will remove these things. So after pre-processing our data, we will left with 12,000 images approximately. So we will remove approximately 1,000 images, and then for the hyperkinesis, we will remove approximately 2,000 images. then the actual data set would be 33,000 images. So we have a data of 33,000 images, and we need to build up a machine learning model on this. So we need then comes to the conversion. So we have a data in this domain. Okay. So as I have told to you people that this is a software micro diacom viewers. So these images, there is specified software on which these radiologists will see these images. But we have to convert this into another format. Okay. So I have to use, so there is a software called as DICOM to JPG. We can use that particular thing also. Then there is a software called as MATLAB. So I have used both the software as well as tools, or I have other write my own code to convert all these images in one go. So micro DICOM will take approximately, when I was doing this type of research in 2019, so it will take, I think, 4 to 5 hours to convert. So over here, the computational power will come into the existence. So we need a great computing power over there. So if we don't have a great computing power, then we don't use this type of image processing. So we need a high-end workstation for that also. So when I was doing this type of thing, then we have a good systems available at the university. So I have used that micro DICOM, and then we have used that softwares through MATLAB. I have used both the systems. So we have write down my code, and then this code will run automatically. And then when I will leaving the university at 5 p.m., then I will start this code, and early in the morning they will convert it with all these images. So I'm doing this thing on the daily basis. Then it will be look like this. So I have arranged these all the images in this fashion. So all the images will be that particular folder. So these are the normal images, then these are the hyperkinesis images will be arranged particularly ranging from 1 to. So again, there is a one challenge. So we have to rename these images. We have to rename all the images up to the 13,000 times. So we have to use some techniques to do the normalizations. So we have the labeling of images, again a challenge. So we have to do through this medium, or we have to write some code also to do this, or we can just use some tricks also. So it will take, I think, 1 day, or sometimes it will take half a day also. So it will depend. If you know the tricks, then it could be done within a half an hour. But running a convolutional neural network. Okay, so what we have done in the convolutional neural network. So this is a standard example. So this is an image, and image is composed of pixels. So as we know that the image is composed of pixels. So this is a cat image. Okay. So we have an image, and it is composed of pixels, and then these are the pixels. So what we have to do, these are the pattern in our image. So every image has a particular pattern. Okay. So the value of these pixels, if it is a RGB color, then it's ranging from 0 to 55. That means that we have a total 256 value. But if it is a black and white image, that we have to do, if it is a black and white image, then ranging from 0 to 127. So total we have a 128. Okay, ranging from, so 0 means black and 128 means white, and then RGB for 0 to 256. So these are the color schemes that we have to use to build up our model. And then again, if we have two images, just like as black and white images, then this comes under the category of that binary classifications. Let's suppose we have images of herd, or we have a black and white image. So this is a binary classification. Means we have either a person is suffering from this disease or not. So we have values of 0 and 1 only. If we have a color images, then this is a multiple classification. Okay, we have to classify all this in the different classes. Okay, so this is, in our case, we have a binary classifications. So we are going to build up a binary. Then comes to the, if you talk about the neural network. So earlier I have dictated to you people that this is the simplest neural network. So we have a nodes available over here. So these are our nodes. Okay. So what does it mean that fully connected layer? What does it mean? It means that all the nodes that are available in that particular uh, neural network, all the nodes will be connected to all the data sets. Okay. So this is the fully connected layer architecture, FCC. There might be a one node that would be connected, or there might be a multiple nodes that would be. So this type of architecture is called as fully connected, means that all the nodes will be connected to the one another. So data would be flow in much more fashions. So what does it? So in the convolutional neural network, we have a image of 32 cross 32 cross 3. So that means that it's a color image for that particular example. We will stretch it to up to these pixels. So we will take these all images in a one single fashions. So all the pixels that we have for the particular image, okay, we will stretch into that single unit, and then we will perform the weight matrix. We will apply some weights, and based on these weights, we are getting our activation functions through which we will get our output. So we are getting the linear activation function, then we have binary. So it will again depend on this activation function, that how we are going to build up our neural network. So there are softmax classifier, then we have a ReLU, then we have a 10H. So these are all other activation function which we have to learn later on. Then convolutional layer. So how this convolutional neural network will perform. So this image, okay, particular height, width, and depth. So this is a convolutional neural network. So all those pixels from this image to next layers, there would be filters which will stride from this image, and then it will go to next image, and it will calculate the dot product of that particular pixels, and through the max pooling technique, we are getting our output. There are some pooling techniques also. There is a max pooling, there is a mean pooling also, there is average pooling also, through which we are getting the output. Through this convolutional neural layers, we are getting our output. Then this is a convolutional layer. So these are the filters, okay, through which each filter will go over there, and in this way your pixel will look like, okay. So it would be going over there, and it will, so this filter has some values. It's like as a 5 cross 5 cross 3, and this is called as stride. Okay, stride. Okay, so there is one mathematical formula through which we are getting the shifting of that particular value, and we are getting the value of stride, that how many strides are needed to get that particular image. So these are the pixels. So when we calculate the dot product of this particular thing, then, and we get some values. Okay, we get value, and for that we apply pooling technique. Okay, so over here the max pooling is used in maximum of the cases, but we have to depend that we have to perform the max pooling and average pooling, mean pooling. So it will depend on the literature review also. So when we build up a machine learning model, then which type of literature is available, and what type of research community has done. So it will depend on the literature. So we have to dig into the literatures, and then we have to find out that, okay, so this is the literature review, and we have to the person has done average pooling, then let's try average pooling, and person has done the mean pooling, then we will apply the min pooling also, or a person has done this, and we can apply the combination of these three, and then we will look into out that okay, so the model will work in the best sense. So in this way, all the convolution will takes place, and then we will get our output. So this is the thing which I was talking about. So it will go into, and then we'll getting the output. So in this way, this all will things I'll do. Then we will apply some biased values also. What does it mean? That biasness is this thing that let's take an example of that particular image, and our image is composed of pixels. Okay, so let us suppose our image is 100 cross 100, and we need 150, or we need a 110 cross 110. Okay, then what we will do? We have to make this image to 1 cross 10, 1 cross 10. So what we will do? We will add biased values in our pixels. Okay, what are these? These are filled with some same values, just like as we will fill this area, particular area, with black color. Okay, so black color means that we have a same value, 0. Okay, we will fill it with 0. Okay, so when we filled up with 0, okay, so all the things will be filled with this, all the area will be filled up with 0, 0, 0. So our image will be converted into 110 cross 110. So when we apply the dot product, okay, so nothing will be changed over here, because when we something is multiplied by 0, so it doesn't make any effect, and it doesn't make any sense also. So this is called as a biasness. So we have changed these values, and our work has been done, and it doesn't affect our model also. So this is called as biasness. Sometimes we have to remove some values also, sometimes we have to add also, but most of the cases we will add. Okay, or we will remove the biasness also. So it will again depend on the type of data, or what type of thing we are going to use. Then this is the activation maps. Okay, so it will define that how your data will be look like. So these are your data points. Okay, so if you has a linear activation functions, so it will look like this. A simple linear line will be drawn, and then it will classify whether this is a tumorous cases, or this is a, 1 second, I will check. I will take a eraser. Okay, so activation is done. So this is your typical data points. Let's suppose these are data points. These are data points. These are data points. So activation functions, what does it do? Most of the people will confuse this activation layer. Why we need this activation layer? Why would this need? So these are your data points. Let me change the color pen also. So these are your data points. So when we will use this activation layers, then it will simply draw a particular lines. Okay, so it will classify that person, that image is, I'm sorry, predicted for the heart disease or not. Okay, or we take an example of cancers. So we have malignant or benign also. So let's take M or B example. So these are the triangles is positive, and these are the negative results. So when the best fit line is drawn, okay, so this is your best fit line. Activation function will decide which this line will look like this. So if this is a linear activation functions, then what about these values? this is not a best fit classified. That means that we have to change our activation functions. So to avoid this type of problems, we have activation functions like relu, like softmax. Okay, softmax functions. So what they have done, they have draw your best fit line look like this in this fashion. Okay, so now your accuracy will improve. Okay, so these all the comes under the positive sides, and we have a best fit lines. So this activation function will help us to improve our network and our model also. So we have to use, again, depend on our architecture, that which type of model we are going to use. So someone try relu also, then we will use the softmax also, we can use 10h also, we can use leaky relu also, we can use the binary activation function also. So when we have built up these type of model, we have built up different machine learning model, then we can get our values, or we are getting the different outputs also. Okay, so in this way your activation function and all these things will work, and then these are all the activation maps. Okay, through which your data will transfer from one layer to another layer to another layers, and it is taking the x1 plus w1, and then it is uh, getting so values. 1 second. So x1 plus x2 plus x3. So these are your input up to xn values. So these are your input parameter values, and then we have w1, w2, w3 up to wn. So this is your weight matrix. So again, weight matrix calculate, and we are going to we are getting the dot product, and then we are getting our output. Okay. So in this way, the convolutional neural network will look like, which I have built up. So we have images, and then it will go up to, and then we are getting. So this is a fully connected layer. FCC means that each node is connecting with the different nodes and FCC. So if we have a, now assume if we have a 100 cross 100 node, 100 cross 100. So how much big computation power will be needed? Okay, so that's why we need a computational power, great computational power to run these models. And if we have a data sets, then we are going to get a different specs. So this is a detailed network, so through which we are getting the output. So I have a 28 cross 28 cross 1, which is convolved through 5 cross 5 paddings, and then it will perform the max pooling and then different layers, and then we are getting the output. Okay, so we are getting our different outputs. So these are the networks that we have built up. So initially it is a 20 cross 24 cross, and then we have a 12 cross 12 cross n1, then we have 8 cross 8. So every time when this passing to the next layer, your filter size is getting reduced, so your channel get reduced. So and the end we have flattened layers, and then this is a relu activation function, and this is a fully connected layer. So this is a 4-layer network architectures through which we are getting the output. So this is a hyperkinesia convolutional neural network, which I will explain by tomorrow, that how this will work. And then so this is the work, and in this way your data will be look like when we have to or normalize your data. So when we normalize our data, and we will look into Excel sheets. So when we have a data of 30,000 images, so there is no software which can handle this much of data. So this is a little bit snapshot. Actually, at that time my system will hang up, so but I am able to capture this snapshot. So we have to use the Linux based repository. So we have to familiar with some particular commands, just like as a grep, or um, uh, or there are some another commands also, so through which we are getting the particular chunks of lines of that particular uh, particular file when we get all the normalized data in that particular file or in the notepad files. So we through the terminal we will get this all the data. So in this way, when we have load our values, so what I have done over there, that I have told earlier that image is composed of pixels, and so I have initially set 50 cross 50. So this is a 50 cross 50 image. Now imagine we have 30,000 images and each image is 50 cross 50. So how much size of your data would be? If image would be approximately 10 KB in size, then take a little bit of math and calculate the how much data size would be. So that's why we need a algorithm which will process your data in much more faster way than as compared to the previous ones. For the typical image that our camera will capture or DSLR will capture, that is approximately ranging from 1 MB to 10 MB. So how much processing power is needed to process that particular things? So that's why we need computing power. And as the after 2010, when there is advancement in the hardware, or when the GPU that NVIDIA companies like NVIDIA, they have computing with parallel computing, and the parallel processing will take place, then we are able to run these algorithms. Although these algorithms are available earlier also, but at that particular moment we don't have that much of computing power. So as this NVIDIA get companies get advanced in much more way, and the new hardware will be accelerating, and there is a much more data transfer rate, then these algorithm will work and they will performing much more better way, and we will giving us better results. So uh, so at that particular moment I have only these images with the pixel size of 50 cross 50, and then we have taken that image into array, and then there is a library called CV2 through which we will get convert these all the images into grayscale, and then when we show this image, it will look like this. Okay, so when we load these images, so over here all the images will get load up to develop or to run our machine learning model. So we have 12,000 images and 20,000 images. After that, I have removed some more images when I have built up our machine learning model. So in this way, so when we run our data set, so this one is the data set which we have initially got. Then what I have done, we have split our data into training set and validation set. Okay, so training sets, then again there is a hypothesis 70-30, 90-10, 50-50. So it will again depend on the literature, and research has done so many things. But yes, the best suited way is there is a test set, there is a training set, also there is a validation set also. So when I was doing my master's, so at that particular time there are two hypotheses are going on. Okay, so people are developing training set and validation set also. Then comes to the test set also. So there is a training set. Okay, then there is a test set. Okay, then there is a validation set also. So now the latest hypothesis say that we have to use that 60 for the training, and then 30 for test set, and then for 10 for the validations. Because some people will do that okay, so when we have a less data, let's suppose we have a less data, so we will use the k-fold cross-fold validation technique. So in this k-fold cross-fold validations, the all the data will be jumbled up. We don't know the training set, although we don't the test also. But if we use the validation set, we will keep this data outside of that particular window, outside of the particular training set. We don't use this much of data. We will use this data for the real-time environment. So over here, if you don't use the cross-fold, k-fold, cross-fold validation, then this data will not used in the training, whether in the testing purposes, not in. So this would be used for the validation purposes. So this is a new hypothesis: 60 for training, then 30 for testing, and then 10 for validation data. So in this way, we will split our data sets. And then there is a hypothesis called as 70% of splitting, 90% of splitting. So I have developed and I have split our data into different domains, different when I was building up machine learning models. So I've split it to two. So for the training, when we have used 70% split, so it is giving us values like this. So total images would be look like this. So 8,000 images would be of training, then validations would be, then hyperkinesis images would be 14,000. 6,000 is kept for the validation purposes. Then if we split our data into 90-10, so 11,000 images will be used. Hyperkinesis, so total will be 20,000, 29,000. So in this way, we will use data splitting techniques and we will perform and we will run our model. Then I have used one more techniques. So earlier I have explained that I have used 50 cross 50. So over here you can see that I have used 40 cross 40 also, then 80 cross 80 also, then 150 cross 150 also. Okay, so then I have used one. There is a one sample, one model that I have trained would be 1,000 cross 1,000 also, then 500 cross 500 also. Okay, so then 300 cross 300 also. So again, it would be a challenge for me on these days also when I was doing my masters, that I would just start click and then wait for 2 hours, go for a tea or any canteens or talk with my friends, another research follows, and then come, then you're getting a data get loaded. Then again, I will do that click and then go for do my research paper, do my another work, do my writing and other thesis writing, compilation and other things, and comes to the system and then this. So it would take so much of patience also, then so much of time consuming, then so much of when you don't have so much of hardware computational power and you want to perform this type of task. So when I was running this 1,000 cross 1,000 images, so I think it would take 6 hours to load that particular data set. Then for the training, so it would take, I think, 3-4 days or 5 days. I think I have run for 1 week. Yes, I still remember I have run for that system for 1 week to get our results. So these are the results that we have got. And so for the training purposes, so these are the timestamps that the system will give you when we have, and then these are the losses. Okay. Then we have got the accuracy 92, 94, 96 when we initially run. So this is the first time when I have run when I have built up my model, machine learning model, the complete pipeline will be built up and we are getting the accuracy. I have run for the 3 epochs only. And then we have splitted our data into 90-10. Okay, 90%, 10. So in this way, we are getting our accuracy. So 95, 94. So much more important is that validation accuracy. So over here that we are getting the test set training set, we are getting 94%. And on the validation set, we are getting the 93% accuracy. So that means that we have some type of loss when we are performing our model on that particular validation set. We are getting a different output. Okay.